So here we have two constant vectors a and b, and we need to integrate vector a crossed with the second derivative of the vector valued function r with respect to a scalar parameter t equals to the constant vector b. So let's begin. So here what we will do before performing the integration, we will use the fact that when we take derivative with respect to t of vector a crossed with the first derivative of vector r with respect to t, so that's going to give us a vector crossed with second derivative of vector r with respect to t. So you can check that out. All you have to do is consider vector a as the first function and vector dr vector over dt as the second function. Apply the product rule and you should get this particular result. Similarly, if we take derivative with respect to t of vector a with vector r, so this will be equals to vector a crossed with the first derivative of vector r with respect to t. Same logic will be used here. Use the product rule to obtain this particular result. So we'll be using these two results. Now coming to a question, so here we have to integrate a vector crossed with the second derivative of the vector valued function r with respect to t equals to b vector. So let's integrate both sides with respect to t. So we have integration of vector a crossed with second derivative of vector r with respect to t. We'll multiply it to dt. So that will be equals to b vector is a constant vector. So we have b vector multiplied to integration dt. Now here we can use the fact that instead of a vector cross the second derivative of r with respect to t, we can replace it with first derivative of a vector crossed with first derivative of r with respect to t. So let's do that. So this will get replaced with the derivative with respect to t of vector a crossed with first derivative of vector r with respect to t. dt equals to b vector times integration of dt. The integration of the term on the left hand side will be simply a vector crossed with dr vector over dt. This will be equals to b vector times integration of dt, so that's simply t, plus a constant vector, so let's call it c1 vector. So we will label this as equation number 3. Now what we'll do, we'll integrate both sides of equation number 3. So that means we have integration of vector a crossed with the first derivative of vector r with respect to t. So we are integrating with respect to t, so we'll multiply with dt, and this will be equals to b vector times integration of t dt plus c1 vector times integration of dt. So we will use equation number 2 and replace a vector crossed with the first derivative of r with respect to t with derivative with respect to t of a vector crossed with r vector dt. So that's equals to b vector times integration of t dt plus c1 vector times integration of dt, which is going to give us a vector crossed r vector on the left hand side, and on the right hand side we have b vector times integration of t dt. So that's 1 over 2 times t squared plus c1 vector times integration of dt is t plus another constant of integration which will be c2. So everything has to be a vector. The constant c1 vector is a vector. That's because here on the left hand side we have a vector quantity, b vector t is a vector quantity. Then this equation will only make sense if c1 is also a vector. Similarly, c2 must be a vector as well. That means when we integrate, we should get this final result, a vector cross r vector is equals to half t squared times vector b plus c1 vector times t plus c2 vector. That's the final result.